All right, we're recording. Okay, for those of you listening at home, howdy. I'm coming on screen right now. Thank your classmates for saving my bacon and telling me to hit the record button. And we're finishing up the notes on the quadratic formula and some thingies to associate with it. And getting my water. What is the quadratic formula? It's x equals what? Off the top of the head. Go. A negative b. Okay. Square root of b squared minus 4ac all divided by 2a. Correct. This is the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. This solves ax squared plus bx plus c equals 0. That's its purpose. I mean, it's fun to memorize and everything, and you can get extra credit points sometimes. But the main purpose of it is to solve a quadratic in standard form. For example, solve the following. 2x squared minus 2x plus 1 equals 0. Somebody talk me through that? How? For example, Josh, what would you do first? Exactly. What is a equal to? 3. Compare it to here, and I'll keep going. Negative 2. Good. Always switch to add the opposite. B equals negative 2 and C equals 1. Is everybody clear on that? If it's in standard form, you should be able to pluck out the coefficient of the first, second, and third. Those are A, B, and C respectively. Do it. Becca, help me out here. X equals what? Yeah, negative 2, which you're right, is 2. You can always use parentheses when you plug in. Go ahead, sorry. Negative 2 squared. Okay. 4 parentheses 3 parentheses 1. All divided by 2 times 3. My strong suggestion when you do any big formula, when you do any formula at all, but especially when you're substituting numbers into a big formula, put parentheses around everything. When I make an answer key, the reason I do this is because you don't know the meaning of horror until you're grading a semester exam. And you grade them all, record the grades, and everybody goes home, and then I realize my answer key is wrong. I speak from experience. Whiteout City. I used like 2 of those bottles, like whiting out all of the red marks that I made on all the papers that were not wrong. And then I whited out all the grades, emailed the person, can you please change these 15 grades because I'm an idiot and they're all wrong. So what I do now is I do this. X equals negative parentheses plus or minus the square root of parentheses squared minus 4 times parentheses parentheses, all divided by 2 times parentheses. I deliberately do that. It doesn't take that long. It took me like 5 seconds. And then I just plug in the numbers as is. It makes a big difference, especially if you're plugging into a calculator with the parentheses around it. A calculator thinks that negative 2 parentheses squared and negative 2 squared are 2 different answers. The calculator thinks that this is 4 and that this is negative 4. It makes a very big difference. And this is true, by the way. The square only hits what's directly below it. If it's all one big parentheses, it'll square the whole parentheses. If it's here, it just squares the 2 and doesn't square the negative. So you're stuck with negative 4. Let's do this. I've got to pick a take over. What is this really? 2 plus or minus what? Positive 4, good. Minus, sorry? Yeah, 4 minus 12 over 6. Interesting. Who's feeling brave or reckless? Nick, help me out.
Well, that's gonna be negative 18.
Say again?
Plus or minus 2.
Plus or minus square root of what?
8.
Negative 8. Actually, right the first time. Negative 8. Over 6.
And then
What's up with
you
this?
have to plot an I.
Yeah. That's not horrible, I know. But is there a perfect square in there?
Yeah.
Like what?
4.
4 times what? 2 times. And then how do you get the I out?
Negative 1.
Yeah. Split the radical negative 1 off on the end. That'll give you an I at the end. So what does that boil down to? Okay. What is that really? So 2 plus or minus what?
2 radical 2 radical 2.
2 radical 2 I. Do me a favor up here. If I just put an I here, there's some confusion as to whether the I is being square rooted or not. Put an extra set of parentheses around there, just so nobody worries. All divided by what?
6.
And I leave it like that. Oh, math people. Mary? No. What needs to happen? How do you reduce that? Correct. So what are you about to do? Here's a little hint. X plus 3 over 2 equals x over 2 plus 3 over 2.
So you have to separate those.
Right. Separate the fractions. Go ahead. X equals.
Plus or minus.
Well, reduce it in a minute, but 2 over 6.
2 over 6 plus or minus 2 rounded to 3I over 6.
Over 6. And I like to put the I where? Afterward, right. And now go ahead and reduce that for me.
So 1/3.
Uh-huh. Plus or minus.
1 rounded to 2.
Yep.
Over 3I.
Correct. And the 1 in front of the radical is optional, totally up to you. That is your pair of solutions. So then, put together 3 different things. First, knowledge of what the quadratic formula is. Second, how to reduce radicals. Third, how to split up an answer so that we can reduce it completely. And you get an imaginary thing to boot. Questions? Okay, the last thing I need to tell you is something about this b squared minus 4ac thing. What is this called? There's a special nickname for it. I gave you the notes yesterday. Here. The discriminant. Discriminant, hence the name, it discriminates, not in the evil sense, but in the, like, if you go to the market and you discriminate between rotten tomatoes and good tomatoes, that's a morally good thing to do. You don't have to, you don't have somebody walking up to you, no sane person anyway, you're discriminating against rotten tomatoes. Yeah. Well, it's discrimination. Yeah. It's good discrimination. What they're talking about is unjust discrimination of judging a human being based on something that's not worthy of them. So tomatoes, feel free to judge all day long. Bad tomatoes, bad. So, that was stupid, I don't know where that came from. But discriminant discriminates between different types of solutions. There are 3 possible types of solutions. To a quadratic function. So if you have a quadratic function, there are only 3 possible types of solutions you could ever get. The first type is 2 real solutions. That's what usually happens. Because when you square root, you have plus, minus, and so you have 2 real solutions. The second, which is kind of rare, 1 real solution. And the third is 2 non-real solutions. Kind of like what we just got here. That's a non-real pair of solutions. Non-real could mean imaginary, or it could mean complex. But there'll be two of them. So how do you know ahead of time what you're going to get? To refresh my memory, somebody, this is going off a little bit in the past, but there is another word. There are actually 4 ways to say solution. Solution is one. What's another word for solution? A solution is also known as, what's that? Say it, you got it. X-intercept, correct. A solution is also called an x-intercept. I'm going to put parentheses if it's real. It's also known as something else. A root. And it's also known as something else, which is the fanciest word of them all. The book was asking me for this. It's going to give it away if I give you the first letter. Yeah.
Zero of the function.
Zero of the function. Sometimes just called zero for short. A root is the same as a solution. It's the same as an x-intercept if it's real. It's the same as zero the function. The reason I bring that up, I'm talking about 3 different types of solutions. That's also 3 different types of roots, 3 different types of x-intercepts. So what happens when you have 2 real solutions? I'll tell you, if you look at, you can actually look at the graph of a parabola and know ahead of time if there are 2 real solutions or not. Can you tell me how? What's another name for root or solution method? X-intercept. How would you know if there are 2 real solutions? Just 2 x-intercepts. Like this, or like this. In other words, if it hits the x-axis twice, then you know you're just looking at it. 2 real solutions, and they're 2 real solutions. How do you know they're real? Because you can see them. Seeing is believing in this particular case. Is it possible to have 1 real solution? Is there any way to pull that off? Right there. How so? Yeah, you time it so that it just perfectly hits the x-axis once. We call that a tangent point. You can also do it upside down if you want it. So if it hits the x-axis only once, then you have 1 real solution. 2 non-real. That's also known as 0 real solutions. Is that graphically possible? Think. Right. If the parabola misses the x-axis altogether, or down here, if it doesn't hit the x-axis at all, then it has no real x-intercepts and no real solutions. Now, it's a little funny to say that there are 2 non-real solutions. If I say, where does this graph, like, here's a quick example. Y equals 3x squared plus negative 2x plus 1. Can somebody tell me where that hits the x-axis? Thank you. What do you think? I'm actually glad you're saying that. It hits here, quote unquote. What does that mean? It hits at 2 imaginary places. It's kind of like, if I feed you 2 imaginary meals, you're probably still gonna be hungry. I tell you, man, unless you have a metabolism that's way different than mine. So where are the x-intercepts? Fair question. exactly. It's like this. It's hitting 2 imaginary times, which is a funny way of saying it doesn't hit at all. Okay. Why would anybody bother saying, why even do the I thing? Why not just saying no solutions? Well, in more advanced math classes in college, they actually start graphing imaginary numbers. We're gonna have a little taste of that this year. I'll show you how to graph imaginary numbers, but they're gonna take it way further. If anybody who goes in to become a math major, it can be royally fun, by the way. There's some of the most fun math courses are, once you get past calculus, there are some really, really fun math courses. Calculus 1 is okay, Calculus 2 is pretty tough, Calculus 3 melted my brain. I'm just convinced that Calculus 3 is there so that people think, okay, are you serious? You really want to be a math major? Here, Calc 3. It's kind of like putting you through boot camp. Thank you, sir, may I have another? Have a Calc 3 problem. No, mercy. That's kind of how I felt. But after you got past Calc 3, my wife liked Calc 3. She took it as an elective. I mean, I don't think I would have taken it as an elective, but wow, she was a bio major and she took it just for fun. And she's totally brilliant that way. But anyway, moving on. Once you get past, this has nothing to do with the lesson, but just as a plug for math majors, once you get past calculus, there are some mind-blastingly fun classes after that. I'll tell you about them later if you're interested, but which I'm sure nobody's going to go past. Who knows? See the image between these? If it hits the x-axis twice, 2 real solutions. If it hits once, 1 real solution. If it doesn't hit at all, there are no real solutions. That means there are 2 non-real solutions, complex or imaginary. Okay. Now, what does that have to do with this? We can know ahead of time whether these things are going to hit twice or once or no times at all. And it has something to do with b squared minus 4ac. Look up here. There's something that immediately told us, oh my goodness, this is not going to end well. You're going through just a normal quadratic formula, and then what made life really, really interesting? Okay. It's right around here. Normally it's the point where you start doing this and then people pause and say, oh no. Yeah, there's a radical in the negative. Radical -8. At that point, imaginary solutions, right? The instant you see this, b squared minus 4ac is equal to -8. That will tell you right away. It's over here. No real solutions, I'll tell you this. b squared minus 4ac is less than 0. If b squared minus 4ac is negative, you know ahead of time it will never hit the x-axis. Now the fun thing is, if you have a book problem that says find the x-intercepts, and you look at this and you say, wait a minute, the discriminant is negative, stop. You do not have to do another lick of work. As soon as you saw this, if all they were, I just said solve, so yeah, we got to get the solutions, whether they're real or non-real. But if they said find the x-intercepts, I would have screeched to a halt right here and said none. And the problem, move on. Does that kind of make sense? There's no point in going any further because there's no way it's going to have any real solutions. So it won't have any x-intercepts at all. How do you get 1 real solution? Can anybody tell me the one number on Earth where if you square root it, you only get 1 answer? Right? Yeah?
0.
0. If you square root 0, you get 0 and -0, which is 0. That's really 1 solution. That's when the discriminant is equal to 0. So go and write that down. If the discriminant is equal to 0, then the square root is going to be plus or minus 0. It won't do anything. So you're just going to have 1 solution, not 2. That's when you get one of these rare cases where it just barely touches the x-axis. And then 2 real solutions. Can anybody guess what the condition would be? What would happen with b squared minus 4ac in this case? This is the most common. Go. It's greater than 0. It's positive. So basically, if b squared minus 4ac is positive, you get two solutions. If b squared minus 4ac is 0, you have one real solution. If b squared minus 4ac is negative, you have two non-real solutions, no real solutions. Does that make sense? What they're going to do, here's a typical test question I would ask. Is everybody okay with me erasing this one? I know everybody. Oh. Yeah, okay, that was very good. Here's a typical question that I would ask you on the test. Using 5x squared minus 3x minus 7 equals 0. Describe the number and type of roots. Yeah, go for it. So go ahead and write that down. Using 5x squared minus 3x minus 7 is equal to 0. That's a smudge thing. Describe the number and the type of roots. Now again, there are only three options. Two real solutions, one real solution, two non-real solutions. That's what they're asking for here. Can you tell me ahead of time, you can do the quadratic formula to the end. You can actually just solve, and get the very end. I'll tell you right now, that's the long way to do this problem. Let me tell me somewhat shorter way. Nick, what do you think?
Just do the discriminant.
Just do the discriminant. Let's try it. B squared minus 4ac. Go ahead and crank it in. What is B?
Negative 3 squared.
Correct.
Minus 4 times 5 times 7.
Then
Negative 7.
negative 7, good save. Calculate.
9.
9.
20.
Is this plus or minus?
Minus.
When you're all done.
Oh, it is plus.
Plus. So plus 20 times 7 is 140.
140.
What do you get?
Positive 149.
Positive 149. I don't even much care about the 149. I care about the positive. What's your verdict?
It's two real solutions.
Two real solutions. And that's it. Okay. I know in some cases they'll say, here are 4 possible graphs. Which of these graphs might have a discriminant of 12? Well, the 12 is actually not all that important. The fact that it's positive is important. And I'll give you 4 graphs. Actually, let's do that. Assume the discriminant is equal to 12. Which of these 4 graphs could it possibly be? A, B, C, D. Go. Okay. Yes. It's getting all excited there for a minute. Yeah.
B.
Choice B. Why do you say that?
Because the discriminant is a positive number.
What does that mean?
Means two real solutions.
It means there are 2 real solutions, and why did this one seem to be good?
Because it hits x-axis.
Right. It hits the x-axis twice, which means there are 2 solutions that are real. Ta-da. And it's right. Make sense? That is actually all I have for you. So, glory be to God, we actually have an assignment. Is this 1F still?
I believe so.
Yeah. I'll just make that do Friday. A little assignment that could. Number 1F is due on Friday. Go for it. Let me just double check and make sure that's the actual assignment. Yeah. Okay. Let me look in just a second. 1F is yes, solving quadratics. Where did you get it? Yeah.
31 now?
I don't know any either.
Okay. Got it.
Anybody else need 1E? No problem.
I'll flip around. Did I check anybody's one E?
No.
Oh. I'll check this out tomorrow with the answers.
Okay. Do you want to turn the video off?
Oh yeah, I'll get that off too. Yeah, this is gonna be totally exciting for you at home. So think of this as like a station identification. It's actually what the heck. Okay, this is my hand saying, waving goodbye. God bless you all. Get healthy. We miss you. Bye.